Hello. Can you hear me? Hey. My name's Greg. I represent Unique Network, the NFT parachain in Kusama, but today I'm going to talk about the climate, the environment. So, what's the impact of us using the networks, the different networks? So most of the used networks for NFTs are proof of stake still. It's still Ethereum. But mining doesn't happen all in one place. Neither it is evenly distributed. If you look at Cambridge data, you see that most mining happens in the United States, 35%. So some of it is happening in Kazakhstan, Russia, and Canada. That's probably, if you add up all three of these, it's another third. It's another third, and another third is distributed all around the world. So it brings us to an interesting picture. Okay. So these countries are using different sources of energy, and lucky for us, US is using a lot of nuclear power and a lot of renewable energy. So nuclear, even though it sounds dangerous, it's not producing any pollution, unless, of course, there is an accident on the station. But it rarely happens, lucky for us, and it doesn't produce any CO2. So we can put a zero in there just easily. So there's no CO2 produced in here. Renewable energy, yeah, well, no, it doesn't produce CO2. But interesting stuff starts happening when we use fossil fuels. Kazakhstan, which is the second biggest country in mining today, well, if we believe Cambridge, of course, because we know China is supposed to quit mining, but we don't know what really happens. So I choose to believe Cambridge. So Kazakhstan is using a lot of coal. See how much we produce in red bar here. And US and Russia are using a lot of natural gas, which is also producing some amount of CO2. And Ethereum consumes 107 terawatts of energy every year. Terawatt hours, I'm sorry, of energy every year. And that's, at the moment of writing this article or doing this research, I checked yesterday online, it was 300 terawatts. Because the hash rate is always fluctuating, but I'll stay with optimistic number of 107. So what does it mean for us? I'll distract for a moment. I'm sorry, but there it is. I'll distract for a moment. If you visit this website, Jeannie Lemercier is a nice, very environmentally conscious artist, but he started in a different way. He started realizing slowly that he's doing a lot of air travel, and he thought maybe I'll reduce the air travel just to minimize my footprint. And he started a studio where he worked for 2 years, and he was consciously counting every watt hour of energy he was using. And then when he switched to electronic art, of course, so that he doesn't need to travel to exhibition physically. And at the end, he mined an NFT on Ethereum, and what he realized is he just burned more energy than his studio consumed within 2 years. So that's what I was going to show. If you minted a token, an NFT token, to this event, you produced 95 kilograms of CO2. And I checked yesterday. We all together, well, I shouldn't say we because I didn't mine it. I didn't mint it. Because I knew what's going to happen. I knew I was going to produce 95 kilos of CO2, but everybody minted 1,156 tokens. This is equal to almost 110 metric tons of CO2, just this event. Just to give you a ballpark of the idea what it means, you can drive a car, and just normal average sedan car, for about 400 kilometers and produce the same amount of CO2. If you transfer an NFT on Ethereum network, you produce 48 kilograms of CO2. It's like riding 192 kilometers. So that's of course very bad news, but I have some better news as well. We all know we're moving to proof of stake slowly. Slowly but steadily, Ethereum 2.0 starts releasing. We probably will see this network sometime soon, I hope so. The Ethereum 2.0 is still not terribly efficient, unfortunately, because it uses about 300,000 servers right now, and it's supposed to use about 1 million servers. I know these are small machines, they don't mind, they don't have these powerful hash machines that consume a lot of energy, but it's still 1 million servers, it's a lot. So if we do a mint on that network, it's still much better than 92 kilos, 95 kilos. It's 45 grams of CO2. It's like charging your cell phone 9 times. Tezos guys are much better on that sense. We only produce 1.1 gram of carbon dioxide if we use Tezos. It's like shooting 1 hour video, but still, well, it's still considerable. You know, we can say we are at zero at zero footprint. We are not carbon neutral. Another example is Polkadot. It's even better than this. It's producing already. You see, we're seeing already better numbers. There's 5/500th of a gram. It's like breathing for 4 seconds. It's much better. So it's already closer to being carbon neutral because all live creatures breathe on the planet, and we know this is even useful for plants already. They can handle it. But I'll show you that it's not even close to ideal. So here's, I explained how the Polkadot parachains work. Because Polkadot is a network that's supposed to have 1,000 validators. So unlike Ethereum network that's supposed to have 1 million validators, this is much smaller number. How they achieve that? They use nominated proof of stake. So this is it really helps with number of machines that are supposed to run in the or servers that are supposed to run the network. Because nominators can add their funds to the validators, and this is they can serve one validator can serve many nominators. So that's why they reduce the number of validators, and they still have the same network security. This is just design of the network. This is how it's built, and in their design. One parachain is the side network that is served by the Polkadot relay chain. These are these little guys, ABC and so on. So one parachain is served by 5 to 10 validators. So we only, as a parachain, we're only using 1/10 of the network power. I'm sorry, 1/100th of the network power. Because there are 100 parachains, and of course the parachain needs some servers to maintain it. They're called scalators. These are nodes that collect in blocks for a parachain. But it's still, again, the same. Even though there are so few of them, it's still the same network security because we're sharing the network security with relay chain. And look at this picture. So, at this picture. Okay, here again we have some bars. This is a logarithmic scale. This is why ETH 2.0, Tezos, and Polkadot look almost the same here. But you see, where is the parachain here? It's nearly close to zero. You don't even on a logarithmic scale. You don't see it here. This is how little power it uses to mint an NFT. And just as an exercise, I calculated what it's worth to mint an NFT and transfer an NFT on unique network. It's 1.2 micrograms and 1.3 per transfer. Just to give you an idea, if we mint 30 NFTs, it's going to be equal to 1 breath taken. This is even less than a live creature produces in 1 breath. This is and again, this is the same level of security as Tezos, as Ethereum 2.0, and I think as Ethereum 3.0. I'm sorry, Ethereum proof of stake, proof of work. Okay, so if you wanna, I'm not gonna read through this, but if you wanna verify my my calculations, please feel free. And this is the QR code for this deck that has all these links. Feel free to check after me. I don't believe what I'm saying right now because it's too bad to be truth, but I checked it many times. And I hope I just created some awareness of how much CO2 we produce. Thanks. Yep.
I was wondering how would be the numbers on secure rollups like Immutable X or Loopring, and how much would they use by minting NFTs? Second layer solutions on Ethereum, like how would they compare to those solutions, like number-wise? Like for example, Immutable X.
Okay. Well, for the second layer, we should compare all second layers by security, because not all of them have the same level of security. So if you take Polygon, for example, it sure does produce less energy, and it's hard to estimate because it would depend on number of transactions included in this one iteration of the second layer network. But the parachains that I've been talking about, they are sort of a second layer. So that's they are guaranteed to have a security that's necessary. So, hope I answered this. So it's comparable, yes, but it's different level of security.
Well, I was wondering, you know, the big tech companies, they're more and more going into drilling into their own emissions, understanding are their servers running 24/7 on renewable and so on. Is something like that happening also in the general crypto sphere? So at the moment you're doing sort of rough calculations based on available data, but is there something happening to actually analyze what are the emissions associated specifically? How much renewable energy is actually used for the servers? Is there something going in that direction, which I'm sure is much harder in the crypto sphere, but is there a project?
Thanks. Yeah. This slide that I've shown initially, this one, so and this one, actually that's what I attempted to calculate, because this is the grid. If we use renewable energy, it means it doesn't go somewhere else where it could go. So, like we know in the US at least, the grid is all compensating for other, one sources compensate for another sources. You can even mine the renewable energy on your roof. You can install solar panels and you can feed electricity in the network. So if you consume renewable energy for mining, it means somebody else can't consume this energy. So they will use fossil fuel energy. So these bars are calculated for that proportion. And if you check my references slide, you'll see there are calculations for. Well, there is an Excel spreadsheet, well, Google spreadsheet, where I have these calculations. Well, thank you. I think I finished early. But